Let's look at these use substitution problems that involve definite integrals. So when we evaluate a definite integral, we are going to be using the FTC, Fundamental Theorem of Calculus, Part 1. I don't really care that you know that it's Part 1. What I really care about is that you know how to evaluate a definite integral. These integrals, in most cases, are going to need use substitution, but remember that use substitution is simply a strategy. You integrate with whatever strategy makes sense, but this particular homework set is designed to kind of force you into use substitution. So here we go. We've already practiced the use substitution, so I may not work all of these problems all of the way out, but I'll get you started. So for number 95, I'm going to let u equal to the inside function of x squared plus 1, and du is equal to 2x dx. I'm going to use my math eyes to come over here and see that I have an x dx, which is good, but I don't need the coefficient of 2, so I'm going to divide it to the other side, which leaves me with x dx. All right, now I'm going to make my replacements, and so I will have the 1/2 coefficient out front, integration of u to the 3rd power du. All right, now I'm going to stop and I'm going to change my bounds. So to change my bounds, I'm going to take the lower bound. This is a value of x. The problem given is in terms of x. I need to change it in terms of u. So I'm going to bring that x value over here. I'm going to substitute it in place of x. And so an x value of -1 becomes -1 squared, which is +1 plus 1, which is a u value of 2. I'm going to do the same thing with the upper bound, x value of 1. I want to change it into a u bound. So I'm going to substitute in here. 1 plus 1 is 2. And wow, that makes the problem really easy. I don't even have to do the integration. Because I'm accumulating area from 2 to 2, I simply get 0. So you can see that using use substitution made this a much easier problem to deal with. I didn't even have to do the anti-differentiation. All right, let's go to number 97. Not much different there. In number 97, my inside function is x cubed plus 1, so u is equal to x cubed plus 1. Take the derivative, I get 3x squared dx. Over here, when I use my math eyes, I see a 2, not a 3, so I'm going to divide the 1/3 or the 3 over to the other side. There's already a 2 coefficient. I'm going to make that a 2 over 3 because I have the 1/3 that I put in there with that. I see the x squared and the dx. That's a good thing because there it is. So this is going to become u to the 1/2 power du. I'm going to take my bounds. I'm going to take the 1. I'm not going to keep doing this, but just one more time. I'm going to substitute the x value of 1 in place of x. 1 cubed is 1 plus 1 is 2. So the new low bound in terms of u is a 2. And then I'm going to take the upper bound of 2, substitute it in place of x. 2 cubed is 8 plus 1 is 9. So I'm going to do the anti-differentiation. So there's the 2/3. Increase the power by 1, so that becomes to the 3/2 power. Divided by 3/2 is 2/3, evaluated from 2 to 9. I'm going to take the 2/3 coefficient and bring that out front and make that a 4/9 to make my arithmetic more simple. U to the 3/2 power is the square root of u to the 3rd power. So that's going to become 9 to the 3/2 power, upper bound, minus lower bound, 2 to the 3/2 power. So I have the 4/9 out front. The square root of 9 is 3. 3 cubed is 27. The square root of 2 is square root of 2, so that simply becomes the cube root. Oh, wait a minute, what did I just do there? That becomes the square root of 2 cubed. 2 cubed is 8, which I cannot simplify. I can distribute the 4/9, so 9 divides into 27 3 times. 3 times 4 is 12. And then for, that'll be 4 square root of 8 over 9. And that would be a perfectly fine answer. All right, so let's go on to number 99. And I'm going to bring the screen down All right, so I have an inside function in number 99 of 2x plus 1. So I'm going to let u equal to 2x plus 1. The derivative of u is du. The derivative of 2x is 2dx. I use my math eyes to come over here. I don't see a coefficient of 2, so I'm going to divide it to the other side. I'm going to make my replacements, and I have a 1/2 coefficient out front. In place of 2x plus 1, I substitute u. I'm going to bring that up to a negative 1/2 power. I'm going to take my bound of 0, substitute it in place of x here, and that'll give me a low bound of 1. I'm going to substitute the upper bound of 4. 2 times 4 is 8, plus 1 is 9. So again, I'm taking and I'm substituting over here in place of x. Remember, this is the key to success, this box of knowledge. I'm going to keep the coefficient of 1/2 out front, increase the power by 1, divide by the power from a low bound of 1 to 9. So that's 1/2. Actually, I'm going to go ahead and bring that 2 times 1/2 is gone. So that's just going to be u to the 1/2 from 1 to 9. U to the 1/2 is the square root, so I have upper bound substituted. The square root of 9 is 3. Lower bound substituted. The square root of 1 is 1. And 3 minus 1 is 2. Moving on to number 101. In number 101, which is here, we have an e. So remember, often we let u equal to the power. So I'm going to let u equal to negative 2x. The derivative is negative 2dx. Math eyes, I don't see a coefficient of 2, so I'm going to divide it to the other side. So I get 1/2 du is equal to, I'm going to divide the negative 2, and so that is negative 1, and that's going to equal to dx. I'm going to make my substitution, negative 1/2 coefficient up front, e to the u du. Time to change the bounds. So it's just like, no, it's not like magic, but we'll just pretend. So if I substitute 0 in place of x, I still get 0. If I substitute 1 in place of x, I get negative 2. Notice the bounds are out of order. Whether or not you reverse them and change the sign or keep them as they are, you'll get the correct answer either way. If I decide to reverse the bounds and this becomes a positive 1/2, negative 2 to 0, e to the u, du. So when I substitute, I will get upper bound, e to the 0, minus lower bound, e to the negative 2. And so e to the 0 is 1. So that's 1/2 times 1 minus 1 over e squared. Whether you take that to the denominator or not is not really that important. So if you distribute, you get 1/2 minus 1 over 2e squared. And again, if you did not reverse your bounds, you will get the same answer as long as you keep the negative in front. So it doesn't really matter. All right, 103. Let's clear the screen. Let's drag this down just a little bit. 103. So in 103, I have another e situation. I could let u equal to 3 over x, or I can let u equal to x squared. But usually I begin with letting u equal to 3 to the, or the power 3 to the x, or 3 over x. And I'm going to rewrite that as 3x to the negative 1 power. Take the derivative of both sides, so that's negative 3x to the negative 2. Remember, decrease the power by 1. With my math eyes, I don't see a negative 3, so I'm going to divide that to the other side. So that's negative 1/3 du, and I'm going to rewrite this as 1 over x squared dx, so I can see I have exactly what I need. I have the negative 1/3 coefficient out front, e to the u du, making the replacements. time to change the bounds. So if I substitute 1 over here, so I might want to go ahead and rewrite this as 3 over x. So if I substitute a 1, I get a 3. If I substitute an upper bound of 3, I get a 1. The bounds are out of order. This time I'm not going to change them. So I have negative 1/3. Find the antiderivative of e to the u. It's e to the u. Gotta love it. From 3 to 1. Still going to do upper bound, so that's negative 1/3. E to the 1 minus lower bound, e to the 3rd, which is the same thing when I distribute as negative 1/3 e minus plus 1/3 e cubed. Okay, let's go on to 105. Let me clear the screen. Okay, I have an inside function of 1 plus square root x, so I'm going to let u in number 105 equal to, u is equal to 1 plus x to the 1/2 power. Du is equal to 1/2 x to the negative 1/2 dx. I do not see a 1/2 in my work, so I'm going to multiply the 2 to the other side to get 2 du. I'm going to rewrite this so I can use my math eyes to see that I wanted a square root of x with my dx, so that works out beautifully. 2 coefficient in the front. That's going to be 1 over u squared, so I'm going to make that u to the negative 2 du, bringing that out of the denominator into the numerator. Changing the bounds, if I substitute 1, and you might want to go back and now rewrite this as 1 plus square root x. So if I substitute the 1, I get 1 plus 1 is 2. If I substitute the 9, I get square root of 9 is 3. 1 plus 3 is 4. Don't forget to anti-differentiate. That happens sometimes. Increase the power by 1. Divide by the power. From 2 to 4. That's the same thing as 2 times negative 1 over u. From 2 to 4, which is, I can go ahead and get that negative up front. That's negative 2 times 1/4 minus upper bound minus lower bound, 1/2. So that's 2/4. That's 1/4 minus 2/4, which is negative 1/4. So that's going to be positive 1/2 when I simplify. 107. Let's clear that away. In number 107, I have an inside function. This looks like it may be our first encounter with stubborn x. So I'll kind of go slow with this one. 107 is a very special and near and dear problem. So I'm going to let u equal to 2 minus x. Du is equal to negative dx. Now, what I notice here is that I have this troublesome, stubborn, I call it the stubborn x problem. X minus 1. What in the world am I going to do with that? Because when I look over here, I don't see anything that can replace x minus 1. All right, let me undo that because I don't want to put my box around that actually. Okay, so let me substitute what I do know. I don't need the negative, so I'm going to divide that to the other side. So far, I don't have a coefficient. The only thing so far that I can take care of is replacing the 2 minus x and making that u to the 1/2 power. I can replace dx with a negative du. That's all I can do so far. So what am I going to do with this x minus 1? Well, remember, I think we've encountered this in our lesson. We can, over here, solve this expression for x. Get x by itself, so I subtract 2, so I'd have u minus 2 equal to negative x. Divide by negative 1, so that would be 2 minus u is equal to x. Replacing, I'm just dividing both sides by negative 1. So, in place of this x right here, I can substitute 2 minus u. So here in the problem, I wish I had left a little bit more room. Let me go ahead and erase that and make the room. So I had already substituted the u to the 1/2 power and the du. All right, so now I'm replacing just this x with 2 minus u, so that's 2 minus u in place of that x, and I still have a minus 1. All right, let's clean that up. That becomes the antiderivative of, where did it go? I have 2 minus 1 makes 1, so I have negative u plus 1. All I did there was 2 minus 1 is 1, and I have a negative coefficient. I can distribute the u to the 1/2 power, and that becomes negative u, 2 halves and 1/2 is 3 halves, plus u to the 1/2 power, distributing. I was deciding if I was going to take the negative out, but if I did that, I'd have to take it out of both, so I'll just leave it there. So that's the opposite of u to the 5/2 power, that's going to be a negative, multiplied by negative 2/5, plus u to the 3/2 power multiplied by 2/3. All right, I never did change my bounds, so let's go back up and pick up the bounds. You might have to watch this one a couple of times to make sure you get it. So if I substitute the 1 all the way over here, 2 minus 1 is 1, so that's a low bound of 1, a low bound of 1. 2 substituted in here, well, you gotta love the zeros. 2 minus 2 is 0. The bounds are out of order. I can reverse them, and in fact, this time I think I will, to get rid of that negative. So I think what I'm going to do now is I'm going to make this positive in front over 5. Oh, come on, and reverse my bounds to put them in order. I just did that because it conveniently got rid of my negative. So I'm going to substitute the 1, thank goodness for 0, so these are square roots. So the square root of 1 to the 5th power is 1 times negative 2/5 is negative 2/5, plus, substituting 1, the square root of 1 is 1, cubed is 1, times 2/3 is 2/3, minus, 0, upper bound minus lower bound. All right, getting a common denominator of 15, that'll give me negative 6 plus 10, which is 4/15. And again, you might have to watch that again to pick up all those subtleties because it involved the stubborn x. All right, let's clear and go to the next problem, 109. All right, in number 109, we hit trig. We clearly have an inside function of the angle 2x, excuse me, 2/3 x. So u is equal to 2/3 x. du is 2/3 dx. I don't need the 2/3, so I'm going to divide it to the other side or multiply by 3/2. I'm going to put my coefficient of 3/2 out front. I get the cosine of u. Substitute 0 in and get 0. Substitute pi over 2, so 2/3 times pi over 2, the 2's divide out, and that gives me an upper bound of pi over 3. So find the antiderivative, and the antiderivative, go careful, tricky trig, tricky trig. The derivative of sine is cosine, so this becomes sine. I kept my coefficient 0 to pi over 3, so that's 3/2 of sine of pi over 3, which is 60 degrees, minus sine of 0. The sine of 60 degrees is root 3 over 2. And the sine, the y value at 0, the angle of 0 is 0. So that becomes 3 root 3 over 4 as the net accumulated area under that curve. And then we're going to jump to, I believe, if I have this highlighted correctly, let me double check. Yep, 127. All right, so to 131. Okay, all right, make sure I highlighted the right problems. All right, reset. We're going to 127. In number 127, we have an inside function. It looks like stubborn x again, by the way. So u is equal to 2x plus 1. du is equal to 2 dx. I don't have a coefficient of 2. I'm going to divide it to the other side and get dx. So when I start replacing, I have the 1/2 out front. I have the I still have an x in the numerator that I have not replaced, and I have a u to the 1/2 power in the denominator, and I can replace the dx with the du, and I already have the 1/2. So here's that stubborn x that we have not replaced. So I'm going to come over here. I'm going to find the value or the replacement for x, which is u minus 1 over 2 is equal to x. So I can take that denominator of 2 and get it out on the outside. So there's another 1/2. The orange 1/2 came from the from right here, and the second 1/2 came from when we get x by itself, and I can substitute u minus 2 in place of x. That becomes a take-apart problem, so I have 1/4 of u over u to the 1/2 minus 2 over u to the 1/2 du. That becomes 1/4 of u to the 1/2. I'm just doing exponents here, 2u to the negative 1/2. And now it's time to go and get those bounds. A 0 substituted up here gives me a 1 low bound. A 4 substituted, 2 times 4 is 8 plus 1 is 9, gives me a 9. Anti-differentiate, giving me u to the 3/2 times 2/3 minus u to the 1/2 times 2, which makes 4u to the 1/2. Remember, those are square roots. Nice that they gave us perfect squares. Let's make a little more paper down here. Okay, so that's going to be 1. Where'd my pen go? Come back. That's going to be 1/4 of, so I'm substituting 9 in here and here. Square root of 9 is 3. 3 cubed is 27. Divided by 3 is 9. Times 2 is 18. Let me do that again. I started right here. Square root of 9 is 3. 3 cubed is 27. 27 divided by 3 is 9. 9 times 2 is 18. Now I'm going to substitute the 9 here. The square root of 9 is 3 times 4 is 12. So that was the upper bound substituted. Now I'm going to do the same thing with the 1. 1 to any power is 1. So I get 2/3. 1 to any power is 1 minus 4. So that's 1/4 of, 18 minus 12 is 6. And here, if I go to thirds, that'll be 12, 4 is 12 thirds. 2/3 minus 12 thirds is negative 10 thirds. So in here, I have negative 10 thirds on the inside. Again, that was 2/3 minus 12 thirds makes negative 10 thirds. But then I have this negative right here, so that's going to be plus 10 thirds. 6 is 20 thirds. That's not true. Why did I just say that? That was ridiculous. 6 is 18 thirds. That might be a little better. So 18 thirds plus 10 thirds is 28 thirds. 4 divides into 28 7 times, so I get 7/3 if I did not make a mistake. Let me check that. Actually, when I went and read the directions, I just realized that the directions tell us to do this with a graphing calculator. So that's a little embarrassing. Well, maybe not, just a waste of time. So I'm going to re-clear that, and I'm going to do one of these in the calculator for you. So you guys can type them in the calculator and check them with the solutions manual. But let me reset that, and I'm going to pull my calculator out. So I have my calculator, and let's do 131. So I'm going to do a second quit there. Let me clear all of that out. Now I'm going to be doing a trig one, so the first thing I'm going to do is check the mode and make sure that I am in radian mode. So the mode button is right here, and I'm looking to make sure I am in radians, so I'm okay with that. So I'm going to do second quit to get back to the home screen. Now, if you have not gotten these steps down yet, it's time to start knowing them. You can write them down as you hear them. And for those of you who have an older model calculator, I will walk through your steps as well. All right, so the first thing I want to do is a math 9. That's got to become something that is automatic in your head when you're evaluating a definite integral. Math 9 is integration. Math 8 is derivative. So math 9 on your models, it's kind of obvious what to do here. So in number 131, I have a 0 low bound, and I have a, whoops, let's go back down, a 3 upper bound. Now carefully type in the function. We're not going to type in a theta, we're going to type in an x. So I have x plus cosine of x divided by 6, whoops, and then I'm going to put in an x. And so that's really all there is to it. We're going to press the enter. I just wanted you to practice using your calculator on these problems. This is 131, okay? And so if you don't have a newer model calculator, then when you press math 9, so the steps are, number 1, you're going to press math 9. And depending on what model calculator you have is what's going to come up. If you have an older model, it's going to literally type, F int on your screen and put a parenthesis just like that. So whenever that occurs, you are going to put in, this is what you do every single time. You're going to put in your function. You're going to put a comma, the variable of x, the low bound. Whoops, no, not the low bound, you fool. Yes, low bound, comma, the upper bound, from and to, and then you're going to, you don't necessarily have to close the parenthesis, but I just like, I guess it's keeping things in order. I like things in order, so I would close it. So in this case, I'm going to type x plus cosine, and it'll put a parenthesis, x over 6, close the parenthesis, comma, x, and again the comma is above the number 7. The comma is above the number 7. From 0, I started looking at the wrong problem, to 3, press enter, and you will get the 7.377 answer that we got on the new model calculator. So just practice using your calculator, and that's all you were asked to do in that particular set.